I'm here to give a brief description of open and closed sets and the difference between the two. And we're going to start on the real line because the idea is the exact same. I'm going to give you two different sets. And one will be open, one will be closed, and actually I'll give you three. And one will be neither open nor closed. The first set will be 0, 1, but I'm not including either. The second set will be 0 and 1. And I'm going to include both, which we normally write like this. And the third set will be 0 and 1. But how about I include 0, but I'm going to leave out 1. Okay, so you might want to look at the definition of open sets and closed sets and accumulation points and interior points and boundary points, etc. So an open set is one where every point in the set is an interior point. That is, any point I pick in here, whether that one, I can draw a little tiny circle, which a circle in R is an epsilon, or is an interval around it, an open interval. That's completely contained in there. And notice I picked something in the middle, but it doesn't really matter, right? If you pick any small number, like 0, 0, 0, 1, that's contained in a little tiny circle 0.0000001, comma, I don't know, this won't be, I'm cheating a little bit, 0. I don't know, 0, 0, 0, 1, 1. Okay, that's not a circle centered it there, but that's the basic idea. Right, so no matter how small you make the number, you will always be able to find some open interval. So just because you do something right there, all you need to do is make your interval really, really tiny and it'll still be in there. That works for every single point here, so that's why it's an open set. This is not an open set because at 0, I should do this. This will be green. At 0, no matter how small I draw my interval, what am I doing? There we go. I've got the colors right. No matter how small I choose my intervals, I'm always going to contain points to the left of 0. Points to the left of 0 are not in there. So 0 and actually 1 are not interior points. Interior points. So it can't be closed. Or it can't be opened, sorry. Very similarly here, by the exact same reasoning, 0 not is an interior, 0 is not an interior point, so it can't be open. So that's what we mean by an open set, is just, it doesn't contain its boundaries. That is, there's always a little room to your right or your left so that you'll still be in the set. There might not be much room, but there's enough room that you can always be in the set. Whereas at 0 here, if you go just a little bit to the left, you're out of the set. At 1, if you go a little bit to the right, you're out of the set. So closed means that you just contain your boundary points. While the boundary points for all these are pretty clearly 0 and 1, this doesn't have 0 and 1. 0, 1 are not in 0, 1, so it can't be closed. Right, here it is, 0, 1 are in here, so it is closed. And over here, oh, 1's not in, so 1 is not in, and 1's a boundary point, so not closed. So what does this look like in the plane, in the complex plane? Let me give you maybe 3 different examples here. Open, closed, neither. So an example of an open set might be the shape here where I don't include the boundary. No matter what point I pick, I can always move a little bit in every direction and I'll still be in that set. A closed set would be I'd have to include the boundary. A set that's neither is, I'm going to make it so that it's kind of partially open, partially closed. So these aren't interior points over here, so it can't be open. And these are points of the boundary, and they're not in the set, so it can't be closed, so it's neither. That's the basic idea of open and closed sets.